Hi. Today on my table I have some LEDs. I bought these from the world's largest online purveyor, about £1 each, something like that. And I want to today design a circuit to use these LEDs to make a voltage control lighting system for use with my Eurorack when we're playing live. This is kind of a follow-on to the Rorschach video that I posted a little time ago, which is excellent, but what I want to be able to do is also have some other light effects keyed to the music or to CV, use some colour filters as well so that we can enhance the light show as we play. So I bought these online. These are AC/DC 12 to 24 volts. An important part as well is that they're dimmable. So let's get some power, because I'm going to be using DC for this, and we'll just have a look and see what kind of response we get from them. Okay, so I've hooked up a bench power supply. There's no markings on the units for positive or negative terminals, but I do have 4 diodes, so I'm guessing it's got a bridge rectifier. So we'll try it this way around. So I've got the bench power supply set for 5 volts. So let's put that on now. Okay, nothing so far. Let's go 6, 7. Okay, 8 volts. Yep, you can see that. So they're switching on somewhere between 7 and 8 volts. Let's see if we can be a bit more precise. Okay, so that's 7.3 volts. You probably can't see very well on the camera, but I can just see the LEDs starting to light on the centre. So 7 volts then is a minimum. I'm going to tilt it away in case these get very bright. So we'll now go 8 volts, definitely on, 9, ooh, they're quite bright, 10, brighter still, 11, 12. Okay, so it looks like at 10 volts they're pretty much fully on. Okay. Alright, so working voltage of 7 to 10 volts DC then. Okay, let's get a bit of paper and let's start designing a circuit. Okay, first things first then, let's put down a few assumptions or things that I want to work with. So we're going to start by only having plus minus 15 volt DC as our power source, so that's a limitation. There's no wattage on these, but I think we're going to have to assume that we're going to need to provide at least, let's say 1 amp of current. And however we drive it is obviously going to need to be capable of driving it at that kind of level. Might well be considerably less than that, but we'll see. What else do we need? We assume that we're going to use, for now, Eurorack signals. So primarily we're going to be using envelopes and maybe audio. So we'll say 0 to 5 volt signal in. Okay, I think that'll do for now. I might think of some more in a minute. So the first thing we need to do then, so working voltage of 7 to 10 volts output. So that gives us a 3 volt peak to peak output signal. So that's the difference between the 7 and 10. That's our working voltage. So whatever signals we put in need to be between 7 and 10 volts. So let's think about some of these in order then. So 7 volts then has to be our minimum voltage. So there's a variety of different ways we can do that, but let's think if we go with our plus 15 volts in, and we'll call this our DC bias signal, and we could use an LM317 in order to trim ourselves to get 7 volts. We'll deal with how we're going to do that in a minute. We're also then going to need to put a suitable resistor in, but for now what I'm going to do is use a potentiometer, I think, to get the signal going into an op-amp. And we'll go for a standard summing inverted one for the moment. So there'll have to be a resistor here to give us our gain that we want. This is going to be plus 15 and minus 15. And then the positive input would be tied to ground. Okay, so we need then to have some form of resistive chain in order to tell the LM317 that we want 7 volts. So the best way of doing that, I think, for now would be to have something like this. Now, LM317's, this is R1, so it really needs to be, I think the recommended value is 240. We can work out an exact resistance value, but for now we'll just use a 2K pot. That should give us enough flexibility to tune this so that 15 volts in gives us plus 7 volts at this point. And then obviously the gain here, let's say we use 10K. This is probably going to be 10K as well. So if we use a 20K pot, we can make sure that's properly trimmed. So that's our bias. We also need our input. So why don't we use another pot so we can trim the input. Because this is going to be at 0 to 5 volts. And we want it when it comes out of here to be 0 to 3. So if we use another 20K pot, then between all of these we can get these values right so that we have 7 volts plus our 0 to 3 volts at the end of this first stage of the op-amp. So those are our inputs, and we've dealt with that one. And if we select all of these values correctly, then we also then have our 3 volt peak-to-peak output. Now the only problem with this is that if I drew voltage here, the output at this stage is going to be inverted. So we would have our minus 7 volts and then our minus 10 volts, and obviously we want that to be positive. So the best way of doing that really is to just put it straight through another stage of the op-amp, and this time we can be prescriptive of our values. Do another inverting op-amp, and the output here then would be plus 7 and plus 10 swing. Okay, good. So that gets that will probably get our signals and the values that they want. But now we're going to need to drive this particular unit. Again, a number of different ways we can do this, but let's just use a standard transistor pair. So if we have a little input resistor here, we'll take an NPN transistor at plus 15 volts going in, and then we'll take the emitter from that one through another resistor, and then this one then will be the output to our LED. obviously with ground as well, coming on the other pin. This one can be a standard sort of any old jelly bean, really, NPN. I've got a lot of BC547, so we'll use that. And then we're going to need a power resistor, a power transistor, I beg your pardon. So I think BD139. We'll try that. It's not the biggest power transistors in the world, but it comes in a package that I can't remember off the top of my head what package it is. Smaller than TO220. But yeah, we'll try one of these. We'll probably need to put a heatsink on it because I imagine there's going to be a bit of heat to be generated. So yeah, that's DC bias and our inputs trimmed to give us our -7 and our +7 with our 3 volts peak to peak swing. One driving transistor to drive the power transistor, and then out to our LED. Okay, let's have a look at that on the breadboard then, and we'll see how we get on. Okay, here's the breadboard then. We've got our LM317 here with an associated trim pot for it to set the DC bias. That one then goes into its own trimmer for the first stage of the op-amp. Here is the input from a function generator, which has got a 5 volt peak to peak, 0 to 5 volt slow ramp coming in. Again, trimmer associated with that first stage. Here's the op-amp, just using a TL072. We've got the BC547 driver transistor here, and then the BD139 output transistor here. Plus and minus 15 volts. And yeah, let's turn it on. Okay, so we've got nothing at the moment. Let's just get a meter and just see what we've got coming out, because it should be close to 7 volts. Obviously I've trimmed all of these up already, so that I should get the output voltages that I want. So where's out? Out is here to ground. Can't see that. 7 volts, good. Okay, so let's now put the function generator on, and as I say, this is a 5 volt signal running at half a hertz. Oh, look at that. That's plenty bright enough. And it is dimming and doing what it should do, I think. Let's just try going a bit quicker, see how quickly it can go. Let's go 5 hertz. That's pretty good. Okay, let's just put it back to half a hertz. Let's have a look at the power. Okay, it's kind of hovering up to about 100 every now and then. What's it saying on the power supply on the positive rail? We're showing a maximum of 190. So if I slow this right down, well, it would help actually if I had it on DC. 180 millivolts. 180. Okay. Well, that all seems to be pretty good. So I think the circuit is fine. What I'll probably do now is put it on some perf board, make sure that I know, and do maybe a few experiments with fixed resistors rather than potentiometers or trimmer pots, and let's see then how it performs on a bit of perf board, and we'll also have a look at how much temperature this thing's generating. That is warm. It's on a heat sink. I mean, it's not hot, but it is warm. Anyway, I think that's the next step. Get the perf board and soldering iron out, and I'll come back.